Today, we're going to look at some review material that's going to help us in the future with Chapter 6. We're going to look at solving a system by substitution. We'll do some factoring. We're going to multiply by the conjugate, and we'll do some adding and subtracting of fractions. Why is that going to help us out? Well, remember in Chapter 5, we did a lot with trig, and especially with a bunch of these different identities that we started filling out in our flip book. So in Chapter 6, we're going to be coming back to these, and a lot of what we're going to be doing is dealing with some of those skills that I just listed that we're going to review today. So one of those skills is being able to use substitution in order to solve. So notice that in order to do substitution, you have to have an equation with a variable by itself, like we do in the bottom here. So I'm going to be able to rewrite that top equation, and instead of putting that y, we're going to replace it with what y equals, but everything else in the equation will stay the same. We'll start solving for x, so we're going to distribute that 8. So we'll have 4x now minus 64x. That is going to be multiplied to get us 184, and this equals 4. I've got some like terms to combine. And now we'll start solving for x. So notice that we're going to have to subtract 184. That will give us now negative 60x equaling negative 180. And then dividing by negative 60 will give us our value of x to be 3. Now, 3 won't be my final answer because we are dealing with two variables, x and y. So we just found x. Go back to that equation where the y is isolated by itself. We'll substitute now in 3 for x, and we'll be able to start solving for y. So notice that when we multiply those two numbers and then finally combine our like terms, we get a y value to be negative 1. So then as an ordered pair, 3, negative 1 in parentheses, because it's always x first and y second. This would be our solution to that system. When you factor, remember your first thoughts when factoring is to look for GCFs. In the first example here, 2n squared minus 10n, I see that they both have a 2 in common as well as that variable of n. So factor that out, and that leaves you with an n minus 5. Because what I have in parentheses is not factorable any further, then that tells us that this is as much as we can factor, and so we are done. In the next one, once again, if you can look for a GCF, then you want to do that. I notice that there's a 4 in front of x squared, so I'm going to look to see if I can get a 4 out of everything. Notice that this is 4 times 7, and this is 4 times 30, so I definitely have a number that they all have in common. So by factoring out that 4, I can't factor out a variable because they don't all have that, but that leaves us then with an x squared plus 7x minus 30. And now in parentheses, I see that I have an x squared, an x, and a number. So remember that then means what multiplies to the last number but adds to the number in the middle. I got to leave that GCF out in front because now there's no number in front of that x squared term. We can have an x and an x. If I have to multiply to a negative, I know that I'm going to have one negative and one positive. So now we got to find numbers that will then add up to 7. Notice that I have 10 and 3 multiplied to 30. I'll need the 3 to be negative and the 10 to be positive in order for it to add up to that positive 7. And this would be my factored answer. Simplifying, in this case, we are going to be multiplying by the conjugate. Now remember, we talked about this concept of a conjugate last semester. I never want to deal with having an imaginary number in my denominator. And so in order to get rid of that imaginary number, I'm going to multiply by the conjugate. And so the conjugate is us looking at that binomial and pretty much writing that exact same binomial. However, we have to change the sign from a positive to a negative. Or what if that started as a negative, we'd change it to a positive. So basically just flip the sign but keep all the other terms the same. So if I'm going to multiply that by the bottom, I have to also multiply that in the top as well. So now I can multiply fractions going straight across. So it's 2i times 3 minus 4i. And now that's all over 3 plus 4i. times 3 minus 4i. In the top, I get to distribute. So 2i times 3 would give us 6i. 2i times negative 4, well, 2 times negative 4 is negative 8, and I times I is I squared. On the bottom, we're going to start distributing that out. 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i. And 4i times negative 4i. Well, 4 times negative 4 is negative 16. And once again, I times I is I squared. Now remember, anytime I see I squared, that's the same thing as the number negative 1. So I'm going to start replacing all those I squareds with negative 1. So that still leaves me with a 6i, but now I have minus 8 times negative 1 on the top. Notice that on the bottom, those middle terms of 12i and negative 12i cancel, and so now I'll just have minus 16 times negative 1. So we'll have then 6i plus 8 on the top, and we will have 9 plus 16 on the bottom. I want my final answer to be written in standard form, which means I want the real number first and the imaginary number second. So I'm just going to flip-flop the numerator around to be 8 plus 6i. Notice that my denominator now, 9 plus 16, is going to give us 25. And then once again, to be in standard form, I'm going to separate those to look like this, where I've got my real number first, my imaginary number second. I am not going to be able to reduce down those fractions any further. So this would be my final answer. When we're adding rational expressions, remember you have to have a common denominator in order to make that happen. Also, if you can simplify, you can look at each fraction and see if you can do that. Now, going back to this first one over here where we were simplifying, notice that I was not able to cancel out the i's. I was not able to divide by 2 because the numerator was a monomial, the denominator was a binomial. They were not the same factors. Everything has to be as factored as possible before you can start trying to simplify. So looking over here at my first fraction, 4x over 5x, notice how they are both monomials. You can't factor them any further than what they already look like. And because there is something on the top that is also on the bottom, I could technically reduce that down. And that is really just 4/5. But if I look at the second thing here, notice that x plus 6 is a binomial. That's its own factor. There's no way for us to factor that any further. That is not going to end up looking anything like the top. And so I am going to have to leave the second fraction exactly how it is. But now that I see that my two denominators are really a 5 and then an x plus 6, because those are two very different denominators, put them together, that becomes your least common denominator. And so that's what I want my denominators for both of those terms to turn into. So notice that if I have my new common denominator of 5 times x plus 6. If you look at the first fraction, well, what was missing from my denominator? It was an x plus 6. So that numerator of 4 also has to get multiplied by x plus 6. If I look at my second original denominator and what my LCD is, it's missing a 5. So I'm going to have to multiply 5 to that numerator of 4x minus 4. All right, so then I can now make it one big fraction by keeping the denominator as it is, and I can put all of my numerator together. I do want to combine like terms in the numerator, and so in order to do that, I am going to have to distribute. I'm going to leave the denominator in factored form. I'm never going to change that from what it is, but 4 times x is 4x, 4 times 6 is 24. Moving over to the other side, 5 times 4x is 20x, and 5 times negative 4 is negative 20. Still all over that LCD. Combine like terms, 4x and 20x is 24x. 24 minus 20 would give me a positive 4. And then, like I said, in order to see if this can simplify any further, because now I've combined all I could in the top, I'm going to start trying to see if I can factor so then I could potentially reduce. Well, 24x plus 4 on the top, they are both multiples of 4. So if I take out that GCF, that really leaves us with a 6x plus 1 on the top. And notice that if I look at the top versus the bottom, everything's all factored, but there's nothing on the top that's also the same as the bottom. So that means that this would be my final answer. Finally, our last one is subtracting. So notice that once again, if you can try to simplify each of those first, then go ahead and try to do that. However, 5 is a monomial, 3x plus 6. I could technically take out that GCF, and my denominator is really 3 times x plus 2. However, there's nothing on the top that's also on the bottom. If I look at the second fraction, same thing. They're both monomials, so I can't factor, but there's nothing on the top that's the same on the bottom that I can reduce down. So then if I'm looking at my, technically, here's a factored denominator and this, because they are two different things, my goal now is to figure out what my least common denominator is. So if I start with the numbers, I've got a 3 on the outside, and I've got a 2 with that monomial. Well, the first factor that's in common between a 3 and a 2 would be a 6. Notice that x in that monomial is very different than x plus 2, which is a binomial. So this right here would have to be that least common denominator, 6x times x plus 2. So that's what I'm going to be making both of my denominators. And now I can't just keep it as a 5 and a 3. I have to fix the numerators to match my new denominator. So if I look at my original denominator, 3 times x plus 2. Well, I already have the x plus 2, so I don't need that. 3 had to get multiplied by 2 to turn it into 6, and there was also this x. So that means I have to multiply the top by 2x. If I look at my second original denominator of 2x, how did it turn into this new denominator? Well, 2 times 3 would get us that 6. There already was that x, but I also needed that binomial of x plus 2. So now I'm going to go ahead and make it one big fraction by keeping that LCD as it is. Well, 5 times 2x, that's now 10x, minus 3 times 3 is 9, and that's still being multiplied by x plus 2. But now I want to start trying to combine like terms on the top. Notice that it's not just 9 that I'm distributing, it is a negative 9. So we'll keep the 10x, but now negative 9 times x is negative 9x. Negative 9 times 2 is negative 18. Like I said, I am not going to distribute that denominator. I keep the denominator as it is in its factored form. I start combining like terms. Notice that 10x minus 9x is going to give us just 1x. And then because the numerator cannot factor any further and there's no common factors between the top and the bottom, I'm not going to be able to simplify any further, and this would be my final answer.